So which ones do we think are scaled copies? Be careful with our explanations. Make sure we're using copy 1 or copy 2 because we don't want to misinterpret the second image as copy number 2. Richard, awesome. I love your answer, number 1, because yesterday we went over what a scaled copy was. So I agree that copy number 1 is your scaled copy. It looks like it's exactly the same. It's not stretched. Copy number 2 looks like it's that picture that got stretched too long. What do we notice about the angles in copy number 1? So you can add your answer to this same Collaborate board. So if the original and copy number 1 are my scaled copies, what do you notice about their angles? What do you notice about the angles in copy 1 and the original? You all seem to be on it. We all agree copy number 1 is my scaled copy. It's smaller, I do agree with that, but are the angles any different? If you look at the angles in copy 1, are they any different than the copies in the original? What do you think? Perfect, Jordan. That is the correct answer. My shape is smaller, but the angles are not any different. That's key to understanding scaled copies. My shape is either bigger or smaller, but if I move all of the dimensions in the same exact way, then it does not change any of the angles. If I look at copy number 2, those angles look like they're stretched out. So anytime I see different angle shapes, automatically throw it out. It's not your scaled copy. If I move the length and the height of a picture by the same amount and I'm stretching it, it's going to keep those angles exactly the same. So in order to be a scaled copy, we know that the original gets multiplied by a number. We're going to work today to figure out what that number is. And I know the angles have to be exactly the same. Perfect. Okay, what you're going to do right now, if you look at page 17, you can see a lot of different pairs of triangles. I'm going to send a pair of those triangles to your iPad in the draw activity. And I just want you to try to figure out if either of them are scaled copies of the original. So you should be able to see your original triangle O, and then you have triangle A and triangle E. So are they scaled copies? Explain whether they are or are not. And again, as you guys are working on this, I'm just going to let you know that anytime your connection's not working or things aren't loading on your end, you can always try to re-enter the link in Google Classroom. If it's still not working and you're just having a bad internet day, I am recording what we're doing work-wise. So I'm going to post that to Google Classroom a little bit after class, so you're going to be able to see. Okay, so you're going to have 7 more seconds to finish up whatever you're working on. If you're not done, that's okay. But then I'm going to send you my work so you can see this math work that I want all of your problems to look like from now on when we're working on these. copies, okay? So I saw a lot of you having good answers. So a lot of you picked the same one that I picked. I can tell that A is not a scaled copy because it's not the same shape. The angles are different. It's a little bit tilted. It's nowhere near the same. Throw it out right away. Triangle E is my scaled copy, and a lot of you picked that, but we didn't have this language yet about explaining why. So a lot of us could tell that my original got multiplied by 2 to create triangle E, okay? That multiplier that I'm finding, that's what we're calling a scale factor. So that's our second vocab word for the day. We find the scale factor by dividing corresponding parts. So if you notice what I did here, my diagonal side length of 10 corresponds to the original side length of 5. I divided those two sides and I got 2. And notice I did that with the other two side lengths. So my horizontal side length of 6 corresponds to the length of 3, and that gives me 2. And then my vertical side length of 8 corresponds to my vertical side length of 4. When I divide those, I also get 2. So that's what you want your work to look like whenever you're talking about scaled copies. You have to find that scale factor, and you find the scale factor by dividing corresponding parts. If you get the same number, you can circle it, that's your scaled copy. If you do not, then it doesn't work and you would throw it off to the side. Okay? So I'm going to send another pair to your screens for you to work. Now we are going to be looking at triangles B and F. So as we move through these, you can see on page 17, they get a little bit more difficult. So what do we think? B or F? Are either of them scaled copies? And then practice doing that same work that I did. Find your scale factor. Find a scale factor by dividing corresponding lengths. If you get the same scale factor, then that tells you it's a scaled copy. Right now I see a lot of you circling the right answer, which is awesome. But again, remember to show that work. If you're picking one of them, find out what that scale factor is. Thirty more seconds to finish up. Again, show your math work. I want to see that you're finding your scale factor. If you're circling something, divide your corresponding sides out to see what you get. Alrighty, I'm going to share. Oh, I can't share because this one didn't finish, but I really like that one. So I'm going to share with you mine. Again, just so that you can see this is what your work is expected to look like. So right away, I can tell F doesn't work. It's not the same shape. Get it out of there. I don't have to do any math there. But if I notice that B looks like the same shape and I'm going to circle it, I need to prove mathematically that it is. So that means take my corresponding sides. So again, my diagonal side lengths, they're in the same space, so they correspond. So I'm dividing all of my corresponding side lengths. Notice that that's what I did with triangle B and triangle O. And when I divided all of those lengths out, I got the same number. So this one was a little bit weirder because when I divided them out, I got 1. That works. That still makes it my scaled copy. That just means that I took triangle O, I multiplied the whole thing by 1, and it stayed the same. So that's my scaled copy. I found the scale factor of 1 by dividing corresponding lengths. I'm going to skip that one because it's a little bit too complicated. This one gets pretty hard. If we look, now we are going to look at triangle D and triangle H. But notice that triangle D has some fractions in it. Try to see if you can figure it out. If you're circling one as your scaled copy, try to then tell me what the scale factor is going to be. So don't just circle one. Figure out what one is your scaled copy. If you're deciding that's your scale copy, then go ahead and find the scale factor. Scale factor is when you divide the corresponding shapes. Perfect. I see a lot of you circling the right answer. So now we're just working on, if I pick something that I think is a scale copy, how do I find the scale factor? I see a lot of you doing really great stuff. See, all of us picking the right answer, a lot of us doing really good work trying to find that scale factor. Alrighty, so you should have picked, I'm going to share this work. You should have picked option D. Okay, so then if I'm picking option D, I need to go ahead and try to figure out what is my scale factor. So I saw a lot of you doing the same first step that this student did. They came and they figured out what those fractions were. Okay, so that was a great, great, great first step. I also agree that we should be picking D. Okay, I'm going to share this one out because this person went ahead and converted those fractions to decimals. Anytime you're dealing with fractions and you seem a little bit overwhelmed by them, you can convert them to decimals. So now if I have all of those decimals, I can easily go ahead and find what my scale factor is. I'm going to find my scale factor by taking all of my corresponding sides and dividing them. So over here, I did 2 divided by 4 and I got a half. I did 2.5 divided by 5 and I got a half. And I did 1.5 divided by 3 and I got a half. So my scale factor from dividing all of those corresponding sides was 1/2. Okay? I know this one was a little bit intimidating. We had the fractions, but some of you were really, really sending in some good answers on that. Okay, here's an easy one to finish up with you guys so that you don't feel too overwhelmed by those fractions. You have 2 problems. Figure out if they are scaled copies. And then what I want you to do is tell me what is the scale factor from the smaller triangle to the larger triangle. So if they're scaled copies, what is the scale factor that takes me from the small triangle to the large triangle? If you determine that something's not a scale factor or a scaled copy, then you don't even have to go through and divide all of those sides out. sometimes we kind of like the ones that don't work because it means we have to do less math. So if you're picking one of them, remember that you want to find the scale factor. So what is the scale factor that takes me from the small shape to the large shape? Another minute or so to finish up. Alrighty, I'm going to share this student's work with you guys. A lot of you all picked example number 1, which is awesome. That means we're really getting how to find the scale factor. So whenever you're finding the scale factor from the smaller shape to the larger shape, like I asked, you're going to take all of those corresponding sides and divide them out. So 9 divided by 3, 12 divided by 4, 15 divided by 5. All of those division problems that this student wrote is your pairs of corresponding sides. Each time you divide them out, you get 3. So that means your scale factor is 3. You find that number that's the same, that's your scaled copy. Number 2, they weren't the same shape. They're not scaled copies. Get that one out of there. He doesn't belong. Perfect. Okay, so that is your process for determining if something is a scaled copy. Find the corresponding parts, which are the parts that are in exactly the same place in the shape. If you divide all pairs of corresponding parts and you get the same number, that number is called your scale factor. And then your scale factor is what multiplies an original to its scaled copy. So take a minute to answer this question. In your own words, explain what corresponding parts are. You seem to be having some. Perfect. I do agree that we use corresponding parts to make these fractions. So whenever we have those fractions, we're simplifying them or dividing them out to see if we get the same number. Yes, I love this answer. I'm going to like it. Corresponding parts are parts in an original and a copy that are the same. They correspond with each other. Yes. Something alike in a shape. Yes. Corresponding parts are parts in a shape that are exactly the same space. Awesome. I love this answer. When you divide them, they equal the same number. That's what we're looking for whenever we're finding scale factors. If I divide corresponding parts, I get the same number. All right. Next question. Explain what you think a scale factor is. So these were our 2 big vocab words we learned today. Corresponding parts, or parts that are in the same place in shapes. If I divide them and turn them into a fraction, I'm looking for them to be the same number. Now I want you to try to figure out what is a scale factor. Perfect definitions. That is exactly correct. Your scale factor is the number that is multiplying the number on the line to make the shape larger or smaller. So your scale factor is what you're changing your original copy by to make it bigger or to make it smaller. What we use to multiply the number of the original copy. Perfect, perfect, perfect explanations. You divide the scale and the original to find the scale factor. Awesome. Alrighty, so those are our 2 vocab words. So now we know a little bit more about scaled copies. You divide corresponding parts to find your scale factor. If your scale factor is the same, it's a scaled copy. With that being said, I'm going to move us into our last slide for you to answer a question. Okay, so you can only see questions number 1 and question number 2 here. You need to figure out corresponding angle and a corresponding segment. I also want you to try and find the scale factor. So what is the scale factor from the small shape to the large shape? So answer question 1, answer question 2. If you can see question number 3, it's asking you find the scale factor from A to B. So if you answer number 1 and number 2, also find what is the scale factor from the smaller shape to the larger shape. Okay, so I'm going to pause us in our work because it seems a lot of us are really, really good with number 1 and number 2. So I'm going to share my screen with you. So we're able to pick out those corresponding parts. A lot of you got number 1 and number 2 correctly, and then we seem to be a little bit stuck on number 3, which is okay. We're going to spend a couple more days on this. But if I want to find that scale factor from A to P, so from my smaller shape to my larger shape, that just means I have to take the side lengths in the larger shape and divide them by the side lengths in the smaller shape. So notice that I went ahead and counted how many blocks were on my top line. So in my first shape, I have a length of 2. In my second shape, I have a length of 3. If I divide 3 by 2, I get 1.5. So that means my scale factor from the smaller shape to the larger shape is 1.5. Okay. So we are going to talk more about scale factors on Monday and do a little bit more work with that. As far as the rest of your day goes, you have an Edpuzzle video to watch. I am going to mention that today, whenever I go to check that Edpuzzle video, I am going to grade it based off of the questions that you get right. So really try to work hard to answer them and get them correct. That's going to be the score that's going to go in for that assignment. And then you have another task 3 to do with those practice problems. So with the rest of this time, during 9th period, you're working on the Edpuzzle video and then the practice problems that are going to get posted. You do not have to check in 9th period, but if you have questions on anything, I'm going to be here to help. So as long as you are good to go with what you submitted for your Nearpod lesson here, you are free to leave and go ahead and enjoy your Friday, guys. Seda, if your gym teacher canceled your meeting, then you just have a free third period class.